Well, hello and welcome to another SNIA educational webcast. Today we will be discussing multi-tenant, multi-cluster, Kubernetes, and the potential data apocalypse that is coming. I'm your moderator, Jim Pfister, and I am a dedicated contractor to SNIA focusing on application and evangelism and development. My role today will be to act for the moderator as the main speaker, who I will introduce in a second. First, let me introduce you to a couple of key points on the BrightTalk interface. Some of you may not have attended one of these, although I'm sure given the current COVID status that quite a few of us are tired of staring at the four walls and are attending plenty of these. So first, you can expand the screen size. You can see that icon on the just below the screen itself. This may be important if there's details during the presentation that may be difficult to read. Second, there is a question tab. Feel free to ask questions during the presentation. This is delayed slightly from when we're presenting, so I might not immediately get to your question, but as Paul is having his conversations, I will attempt to insert relevant questions, and we will address questions not addressed immediately at the end. We will also be doing a Q&A blog that will be available, and you'll be able to get more detailed answers to the questions there. Third, you might also see an attachments tab on your console. There you will be able to find a PDF of this presentation, so you can download that and have that for later. Although I'd certainly encourage you to listen to the presentation as is, it's going to be very entertaining. And finally, and most importantly, you can rate this presentation. We use your ratings and your comments to improve our presentations, so this will give us a solid indication of whether we're delivering the right quality of content. A score of 1 means you'd probably rather have spent time staring at your four walls, and a score of 5 means that it was perfect content for you. So you're allowed to rate us however you want, but make sure you're doing it with full knowledge. You can also send us comments and feedback on our webcast program and let us know if we're covering the topics that you want to hear about. Please make sure that you're doing that. So as an audio check, let me introduce today's speaker. So today, as I've already said, I'm your moderator for today, and I'd like to introduce Paul. Say hi, Paul.
Hi, everyone.
Okay, so there's Paul, and we'll get to that in a second. Let me go through a little more detail on what's going on. So first of all, before we get into the presentation, there is a little legal detail we need to do. This is a standard legal disclaimer from SNIA. This is to remind you that the material is SNIA copyright. So the material itself is copyright. There might be other copyrights that other companies own within this. SNIA is not providing any legal advice here. We are also not providing any warranties expressed or implied, so you can use the material at your own risk. Third, let me tell you a little bit about SNIA at a glance. So for anyone who doesn't know who we are, SNIA is a global not-for-profit association dedicated to advancing the adoption of storage and networking technology. We do so using a vendor-neutral status to develop industry-wide standards, and we enlist the help of subject matter experts such as Paul in our membership community. And then we provide marketing, promotional programs, evangelism, software enabling to aid the adoption of all of these things. SNIA provides an extensive range of educational materials, and we want to educate, support, and promote, and enable you to understand a lot of the capabilities that the industry is offering to you. So including the webcasts like this one, you'll be able to see our presence at a variety of industry events, should they ever start up again, at a variety of virtual industry events, which are going gangbusters. And we'll also be giving more talks on technology subjects. So without further ado, I would like to hand it off to Paul, and Paul, take it away.
Thanks, Jim. So welcome, everyone. This is the agenda for today. If you haven't gotten the hint from the title of this presentation, including the word data apocalypse in it, we're going to scare you a little bit up front here. So we're going to talk about some notable outages that have happened in the Kubernetes space. Then we're going to move on to some of the challenges that lead us to want to work in a multi-cluster or multi-tenant environment. And then finally, we're going to talk about some of the solutions that have appeared recently in terms of managing those multi-cluster workloads. So that's the rough kind of sketch here. So strap in if you've got any questions. Jim and other folks are standing by to take those questions and relay them here. So feel free to type them in as you're watching the presentation. This presentation also has a lot of links that I will mention. As Jim already noted, there's an attachment of the PDF that should give you some of that content. I think SNIA is usually pretty good about posting follow-ups on their website with a lot of those links as well. So let's dive in. For me, the framing of this, it's really important to think of this quote: a good science fiction story should be able to predict not the automobile, but the traffic jam. So a lot of us can see exactly what's in front of us and what's coming down the lines pretty clearly, but we don't need to just prepare for that. We need to prepare for sort of some of the secondary effects that will happen as a result of that thing that's coming. And that thing for a lot of us is Kubernetes. So that's something I just want to keep in the back of our minds as we're exploring this. So the first case we're going to talk about is a case of a bank in the United Kingdom. They had an outage, and in 2018, they attended KubeCon, which is the Kubernetes conference that happens yearly. That conference, they shared a story about an outage that they had. So you can imagine an outage at a bank being pretty bad news. It's as bad as you might think it is. On a Friday evening, their banking services stopped working, particularly because of a conflict that happened inside of their Kubernetes cluster. So the major issue is they had one giant Kubernetes cluster that was running everything, and they're a relatively talented team, but there turned out to be a minor issue between Kubernetes and etcd. Etcd is sort of like the brain of Kubernetes, and a piece of software that we're using called Linkerd. Linkerd uses Java, or did use Java many months ago. Now it's written in Rust. But in any event, the conflict between those four pieces of technology in a very minor version, very specific mismatch, caused this outage to occur for them. And it was sort of a sneaky outage in that when they initially did the update and matched these sort of versions, nothing happened. But a week later, when they decided to reboot some of the nodes and some of the machines in their cluster, everything sort of spiraled out of control. And the big lesson there is it's really difficult to predict exactly what is going to cause a challenge for your cluster. So even though Kubernetes itself is built with an HA sort of mindset, a single update or a single action can cause your cluster to go down. So really, we want to start thinking in terms of multiple clusters, multiple tenants, and that's what we're going to explore in this next part of the slides here. So with that in mind, looking at Monzo, the UK bank's failure, we're going to look at a number of topics. We're going to talk about security, multi-tenancy, and how Kubernetes up until now has really been largely about managing a single giant cluster very well. And unfortunately, that's something that is changing rather rapidly. So we'll explore, for instance, some writing that Jessie Frazell has done. She's a notable early contributor to Docker. I think she works at Oxide Computing now. And Jessie Frazell is sort of one of those people, if you've ever been to a container or a networking event, you've seen her give a talk. She's one of the better ones out there. She was contracted by the Kubernetes official working group on tenancy to make a suggestion as to what we should do for multi-tenancy in Kubernetes. Multi-tenancy meaning, how do I have multiple organizations, multiple teams, multiple people work inside of Kubernetes? And the conclusion that she came to is that the traditional boundaries inside of a single Kubernetes cluster aren't quite that strong. And to really do multi-tenancy well, her official recommendation is to have a single cluster per team that is operating inside of your business. So if you have a e-commerce team and a ML AI team, each of those would have their own sort of cluster available to them at minimum. Other challenges, security is definitely a big challenge. We talk about this in terms of workload isolation. We also will talk about this in terms of vulnerabilities. So the Billion Laughs attack is a name you might recognize if you've been in the XML space for a while. Essentially, some of these templating or markup languages allow you to create a reference to another object inside of the same sort of XML or YAML template. And if you chain that over and over again in a recursive fashion, you can effectively DDoS a server. So a bug like this appeared in the past year, required folks to update their Kubernetes servers. Other bugs are just simple configuration errors, like Tesla recently had their Kubernetes clusters hijacked and set to mining Bitcoin. So that's another big security concern. And in terms of mitigating these concerns, keeping your clusters up to date is really one of the most important things you have to think about when you're looking at this space. And you can imagine how that becomes a bigger challenge as you add more clusters to the equation. Instead of updating one cluster, you're now updating a handful, or, depending on the size of your organization, if you're following the multi-tenancy kind of ideal, maybe you have hundreds of clusters to match the hundreds of teams that are inside of your engineering group. Another big thing that used to be a unicorn in my mind that is becoming more of a reality these days is multi-cloud. Real companies are starting to really implement this these days. So Snapchat is a very vocal company that has been in the media about contracting with both Amazon and Google as a way of not only increasing the number of options available to them in terms of services that they can consume, but they've also done it just for better cost management as well. And, secondarily, when you look at the clouds themselves, like Google, Amazon, Microsoft, all of them have an answer for this multi-cloud ideal. In Google's case, it's Anthos. AWS has Outposts. Microsoft has something called Azure Arc. So all of these companies are providing a multi-cloud sort of infrastructure for their customers, and that's because it's something that customers are demanding in the real world. So there's a good chance if your company is consuming some of these services, multi-cloud is something that you're talking about, even if it's just cloud that's in your own data center and the cloud provider of your choice that's out there on the web.
So Paul, quick question on that. So from that perspective, you talk about, departments would have their own containers, or they might have their own environments. Do you think they might have their own cloud as well, and that would be the birth of multi-cloud in a lot of these companies?
Absolutely, yeah. That tends to get referred to as hybrid cloud. As you can see in this slide, this is a screenshot I've taken of another SNIA recent webcast that occurred, talking specifically about storage in multi-cloud environments. I think multi-cloud is sort of the bigger term that encompasses both managing your own, what we call private cloud in your own data center, and then the cloud, the elastic cloud that we're used to, that's a managed experience from Amazon or Google or Microsoft. Good question. So this is another presentation that's worth checking out if that's a topic that interests you. And as Jim noted, multi-cloud means multiple clusters, but it's also worth noting that it can be multiple clusters of various configurations. So we need to think that not all of our Kubernetes clusters are going to be running the exact same type of Kubernetes. We may have different teams with different needs. So our different clusters, our different clouds need to be adaptable to those different needs of those stakeholders within our organizations. This is a lot of challenges, but we're getting near the end here. So one of the last ones we're going to look at here is large scale. And, as much as we would like to say Kubernetes doesn't have limits, everything has limits. And you can see this relatively clearly if you just look at, some of the documentation for managed Kubernetes services. This one is Google Cloud's quotas and limits for their own managed Kubernetes service. So you can see things like 110 pods per node. That's essentially 110 deployments. Even if we weren't looking at a managed service like this that is sort of arbitrarily or artificially limiting us, if we look at experts like Josh Rosso and Craig Tracy is the author of a popular O'Reilly Kubernetes book. They have experience managing very large-scale deployments. They are architects that consult with some of the largest enterprises out there using Kubernetes. And one of their recent KubeCon talks, they mentioned that at about 500 nodes, a cluster will start to slow down just naturally. And that's when you really have to either think about breaking that cluster into multiple smaller clusters, or really tweaking the cluster so that it can keep up with the high-scale workload that you're trying to throw at it. So Kubernetes at some point is going to run into problems when you push enough work to it. So there are a lot of challenges that we've covered here, and thankfully we're going to dive into some solutions in a little bit as well. So we're going to talk about some of the ecosystem that's out there that we can look at in terms of hopefully helping solve some of this. Some of it is able to be done today. And then some of the ecosystem is going to be forward-looking. So that's going to be us more looking, if we think in terms of automobiles and traffic accidents, as that quote suggested at the start, that's going to be more about traffic jams and traffic accidents, those types of solutions, things that are coming down the pipeline rather than are here today. Cool. So let's talk about service meshes. This is a new term for a lot of folks. Service meshes are a piece of software that does things like circuit breaking, managing traffic, shaping traffic. The idea is that you place a sidecar or a proxy next to all of the applications that are in your cluster, and then that service mesh or the sidecar for the service mesh basically intercepts and hands off the traffic. So all of these things like exponential back off, pushing back on too much work being sent to it, that sort of stuff gets managed in a consistent way, and that alleviates all of our developers from implementing that logic into the application itself. You know, if we have every developer in every language our organization uses do that same sort of logic implementation themselves, we'll probably get, you know, a dozen different implementations. So a service mesh and the proxy and sidecar sort of setup is a nice way to fix that, such that it's dealt with in a single place rather than a dozen places. So they've become a popular way to manage multi-cloud because of their ability to route traffic, shape traffic, do all of those things. So this is an image of a blog post from Linkerd. Linkerd and Istio are the two service meshes that are really popular in the Kubernetes space. Both of them have some early kind of looks at how to do multi-cloud Kubernetes in a really nice way. So if you are having multiple teams, then you have the ability to easily connect those teams' work across different clusters. Snapchat as well has demonstrated that you can create your own service mesh from some of the components that are out there in the ecosystem. So this is also linked in the presentation. And finally, we're going to look at CubeFed. So CubeFed is short for Cube Federation, and it's the official approach for Kubernetes Federation. Federation really just means managing multiple clusters and having a single point of control for each of those clusters. The same way, you know, we talk about the federal government in America or other countries. You know, you're managing multiple states or multiple regions. Each of your clusters becomes sort of a state or a region that Federation is helping to control for you. So this is a project that's viewable on GitHub. It is in alpha currently, and you can see some of this alpha-ness at the moment just by looking at the fact that, you know, running a command on CubeFed, we have to, our docs here instructing us to create a for loop in bash to then execute the query and receive results. And this is a big problem. This is a really clunky way to manage resources in Kubernetes, and one of the beautiful things about Kubernetes is the fact that we can query all of the workloads that are running on a cluster with a single command. It sort of unifies all of our compute into a single program, and it's presented as a single sort of mass of power that we're able to consume and work with. So if we think in terms of multi-cluster, we want that same sort of power, that same queryability to view all of the available work from a single sort of interface. And that's something that's coming with CubeFed. If you use Kubernetes currently, or you're looking at Kubernetes, there's a fair chance you are comparing some of these Kubernetes distributions we're going to talk about. So Red Hat OpenShift is a very popular Kubernetes distribution, and as pictured here from one of their blog posts, they do have some open cluster multi-cloud sort of management capabilities. And likewise, VMware has been very vocal about some of their multi-cloud ambitions with Tanzu and the recent Project Pacific announcement that they put out. So, you know, the goal here is if you're interested in multi-cloud, these commercial offerings are going to offer a slightly earlier gateway to that. But I think that these are going to differ a little bit from CubeFed or from maybe even the service mesh approach that we talked about earlier. So it's sort of a trade-off of locking yourself, marrying yourself to that platform a little bit more versus kind of adopting the community standard that's out there and is still developing as we speak. So we might look at all of this.
So Paul, just a quick question on that. So from that perspective, do you think that the software can develop fast enough for the community to be able to use it and move forward, or do you think that that basically there's going to be stalls in the deployment of this while we wait for features and functions to be added?
Yeah, I think in particular Istio and Linkerd are maybe a little bit further along than CubeFed. I know some places that are currently implementing their own sort of multi-cluster approach and connecting them together with those service meshes today. They are sort of the early birds to that approach, and I think their challenge at the moment is to think in terms of architectures. So they're thinking about sort of what is the best way to deploy this and set this up, and blog posts from them are starting to trickle in the early days here that are sort of establishing some standards around that. In terms of CubeFed, CubeFed is actually an alpha program at the moment, and it is going beta very, very soon. So I think CubeFed might need, I'd say, a couple months more, and then it should be ready for prime time, and you'll have all of the tools that you need to really assemble your multi-cluster approach. Good question. Cool. So hearing all that, we might think, great, so we've solved all the problems that we laid out earlier, right? We're good to go. Well, the bad news is that there are other failures of Kubernetes clusters that are widely known. In this case, Target actually shared a failure that happened to them. They took an extreme approach of managing many, many very tiny Kubernetes clusters, as small as 3 nodes per cluster within their system. And what they did is they connected all of those systems together using Apache Kafka as a message broker. That may sound smart. Kafka is a very scalable system, and it sounds like a great match for Kubernetes, but what they wind up doing is violating the CAP theorem by connecting all of those different sort of units and piecing them together that way. Kafka becomes a single point of failure then if the message broker goes down. So they in effect did this to themselves. Kafka had an issue. They had an outage as a result. And Target is a very large retailer in the United States. You can imagine the sorts of revenues that they would lose from a multi-hour outage of this type. So, you know, not everything is figured out. Distributed systems are hard. And as we discussed, some of these architectures are still being tested and played with. And that's the thing that we're really watching right now when those of us who are exploring Kubernetes and looking at it on the front line is how do we best set up this distributed kind of federated system such that things are going to work out in a scalable and resilient kind of manner. So what are some of those questions that we're exploring at the moment? Let's dive into those here. So we need to think about traffic routing. We mentioned service meshes as a way to do that cross-cluster. We need to think about how to move our apps and services between clusters. Say one team takes over management of a microservice. Maybe then that microservice needs to be shifted to more of their clusters so that they have the ability to self-manage and do proper DevOps kind of approach to that. That can become trickier if there's a stateful app that's going along with that. And across all of these clusters, we want to think about how are we keeping our security policies consistent.
So Paul, do you think the service would define the stateless or statefulness of the app, or is it really the decision of how it's implemented?
Yeah, I think in Kubernetes, the service will define it. Services tend to push state down, as they say. So at the very bottom of the chain of sort of dependencies, you'll find a database or a storage layer at some point there. And that all should be defined within the manifests that get deployed to Kubernetes. So the service should be very clear about whether it's stateful or stateless. And as mentioned, I think those stateful services are going to be harder just because everybody wants really good app uptime at the end of the day. You know, our customers, whether they're our actual customers who are out there in the world or even just our internal customers, try taking down your staging or your QA environment and see how quickly you hear from your developers. They're going to be just as angry about outages as anyone else. So it tends to be a tricky sort of science at the end of things. But yeah, good question. In Kubernetes world, stateful apps are relatively well defined, so that should be clearly represented on the application. So looking at this, there are some solutions, and that's great. So we have some little annotations here, sort of pointing out, you know, CubeFed or Knative, which is a serverless application. Those are solutions to stateless apps. We can think about Project Bolero, Portworx, Project Astra, Minio, Rookio, OpenEBS. We'll talk about those a little bit later in the presentation. Those are for stateful apps. And then, you know, service meshes, load balancers from the cloud. Those can help route traffic between our clusters. And finally, policy enforcement is thankfully something that Kubernetes community has been looking at relatively early in its life cycle. So there's tools like Calico and Cilium that mix together. It's worth noting that if all of this seems like a lot to you so far, there's a big learning curve to this Kubernetes stuff, and you're just shaking your head thinking like, man, this is just why? Why should I do this? There's a lot of research out there about the demand for both Kubernetes itself and Kubernetes job seekers. Kubernetes itself as a project is one of the fastest growing open source projects of all time. It's been called the Linux of the cloud by the Linux Foundation Executive Director, Jim Zemlin. And then in terms of the job market, you know, this recent article pointed out that over a 4-year time span, Kubernetes has grown more than 2,000%. This is from Indeed.com data, if you're familiar with that, as a job search site. And that's not just 2,000% in terms of businesses looking, it's both 2,000+% of people that have the skill set that are adding it to their resume, and it's also 2,000% in terms of job listings that are appearing that are available and are hiring for Kubernetes skill sets. So this is a good thing to invest in. I do highly recommend that. And we will have some recommendations for where to do some learning on that at the end of this presentation as well. It's worth noting that the solutions that we talked about on one of the previous slides, these are all mostly open source. There's one that's not, which we've crossed out at the top here. The cloud load balancers tend to be proprietary or managed service from the clouds. But you know, every other item on this screen, you know, fits the OSI, the Open Source Initiative definition of what an open source project is. So all of these are available and free for you to tinker with. Go to the GitHub, go to the GitLab, download it, and you can mess around with it and learn from it today. So there's that tends to be really nice in terms of lowering the barrier to entry. You know, the big challenge I think with a lot of these is knowing what project is going to solve what problem when you're just getting started. So hopefully this map kind of helps you out a little bit in terms of looking at matching problems to projects. The one area that I kind of want to zoom in on for the remainder of this presentation is looking at stateful apps, given our audience here. So we're going to talk about Project Bolero, Portworx, Project Astra, Minio, Rookio, OpenEBS as potential solutions for some of those traffic jam problems we're going to have when we're thinking about managing stateful apps across multiple clusters in Kubernetes. Hopefully I've convinced you earlier in the presentation that multiple clusters are worthwhile. And if you know anything about stateful apps, you know that it's hard to just think about stateful apps without thinking about security policies. It's hard to think about them without thinking about networking and traffic routing. So, to some degree, I'm lying to you a little bit by saying we're just going to look at stateful apps, but we're going to carry some of those concerns along with us and at least try and reduce our scope to really just what is involved in a stateful app on Kubernetes. That is our traffic jam scenario that we want to dive into and really explore with the rest of this presentation. So, the idea is that we are hopefully convinced we need Kubernetes. And now, as a storage-oriented person, what do I need to think about when I'm thinking about running a workload on top of Kubernetes? So, I think the biggest thing we probably mentioned earlier is just to really frame the problem in terms of queryability. The tools that you're looking at, if you're going to think about managing multiple clusters, which themselves are managing maybe hundreds of different workloads, you need a single way to look at and address all of the things that are happening inside of that space. So a common way to do that is to have a BI dashboard, but these days it's also very common to have a command line tool that allows you to query and explore some of those results as well. So CubeFed, as mentioned, is one such solution that provides some of that queryability. And everybody seems to have a service mesh these days if they're operating inside of Kubernetes or they're eyeing a service mesh. They're looking at what benefits that can provide. They also tend to have their own command line utility. So these tools will give you that queryability that you're desiring if you choose to adopt them. So things like Linkerd and Istio are great ways to get that. It's also worth noting there's something called the Service Mesh Interface. The Service Mesh Interface, or SMI standard, is something that's emerged because there aren't just 2 service meshes. There are like 10 or 12 service meshes these days. And following this will kind of key you in on some of the quote-unquote maturity of the features as they kind of look across the ecosystem. So as the service mesh interface standard sort of becomes a real standard that's implemented and usable, you can expect each and every service mesh out there to hopefully provide some of that functionality. And standards tend to lag a little bit behind the bleeding edge, I'd say. So this is a relatively good proxy for just if you kind of idly want to follow along and stay informed but not dive into the deep end, check up on this, follow their blog, set a news alert, and the service mesh interface will keep you informed on that. The other thing to keep in mind is a lot of us aren't jumping in feet first into Kubernetes just yet. So we don't really need to think about multi-cluster, multi-tenant workloads. The recommendations that we covered earlier in the presentation, like the Jesse Frizzell recommendation for the multi-cluster, multi-tenant working group to separate workloads or teams by cluster, that is an ideal situation. And for most of us, when we're just looking at Kubernetes, when we're just starting to get going, we're not looking at a deployment that's going to take over 500 nodes. It's not going to have that huge scale. We may not have that need yet. So we can hold off to some degree in terms of tackling these challenges of multi-cluster workloads.
So it's possible to start simply and then expand from there with the knowledge that you have. Does that knowledge transfer fairly well as you get into the multi-cluster, multi-tenant space?
Yeah, that's a great question, Jim. And yeah, it is possible to start simply. And I do think a lot of that knowledge does transfer. I like to think of it in terms of the same way that, your math education tends to, you start out solving basic algebra and stuff in school when you're really young. And as you grow up, whatever other math, trigonometry, calculus, linear algebra, all that stuff, you'll do the calculus, the linear algebra, the trigonometry, and then it'll resolve down to a problem that looks familiar. It'll resolve down to that algebra again, and you still have to solve that and have that algebraic muscle in you. So I think Kubernetes is the same. You can start simply. That'll be your sort of algebra training on individual or simple clusters. And then as you go to multi-cloud, you're going to be looking at introducing those other sort of mindsets. You'll layer them on top. You'll solve those problems, and then you'll see a very familiar looking problem in a sort of single cluster Kubernetes experience. So really just to hammer this home, queryability is absolutely a superpower, and we have to have that if we're thinking in terms of multi-cluster. So if you do come to begin evaluating this, you've implemented a proof of concept and you're happy with maybe the 3 Kubernetes clusters that you're managing by hand right now. As you expand beyond those 3 or that small handful, think in terms of what tools are going to give me this queryability, what's going to give me that superpower, because that superpower is going to allow you to scale to a really brilliant kind of degree, and you're going to need that scaling because the ideal is you're running hundreds or thousands or hundreds of thousands of different types of workloads with this thing. So this is what I see as the absolute essential for avoiding that the proverbial traffic jam that we've been talking about throughout this presentation. So just as a point of reference, if you execute a kubectl command today on a single cluster, kubectl get storage classes, you'll see what storage classes are created on your Kubernetes cluster as this screenshot demonstrates. You should expect that same sort of power from the tools that we're evaluating, and some of those have that today. In some cases, such as with CubeFed that we looked at earlier, that looks a little bit ugly at the moment. But if you're very curious or you're very passionate about the UX of tools like this and you want it to adhere to your specific problems, you want to be able to query things that matter to you as a storage admin, this is a great project to get involved with. CubeFed is in alpha, and as part of beta, they're going to be figuring out some of these querying mechanisms. So, your voice matters. You need to speak up and say, this is something I absolutely need to do when I'm looking at different storage classes. I need to know that there's security attached, or the same RBAC profile is deployed across all of my clusters. Those things they need to hear about because that's going to influence how they develop these commands that we execute. So this is a great one, I think, to get involved with early on. Another option for visibility, it's not just stuff on the command line. There are great projects that are open source, like Project Octant. This is a tool you can download and play around with today. It does visualization of the resources and some of the traffic that's being routed around your Kubernetes cluster. This is a great tool for not just the problem or the challenge of managing multiple resources inside of Kubernetes and multiple clusters, but just getting familiar with Kubernetes itself and what workloads look like when they're running on top of a Kubernetes cluster today. So this is one I highly recommend if you're new to the Kubernetes space. I will say I do have a recommendation for people that are looking to run these Kubernetes clusters. So I think the ideal we want to strive for is mostly homogeneous clusters. So you can imagine that running the same type of Kubernetes cluster, multiple locations, will make our life a lot easier. Unfortunately, if we've been in the microservices space before, some of that winds up being a little bit tricky, and I'm going to use Node.js as a way to illustrate that in detail here. So most of us are most of us are used to the idea of pinning to a specific version for software. So in Node.js, this happens with the VM that interprets the Node.js applications. So let's think about an application that we've named Janglery here, and it used Node.js version 14. That's all fine. That works very well for us initially. And then if we add another application to the mix, in this case named Grillage, maybe that application is something that we're importing as a library or as a dependency for Node.js. So, that may have a different version number requirement for Node.js than Janglery. Development of these applications happens in different places. Most often, you'll have an internal sort of stakeholder, an internal library, and an external kind of open source project that you're trying to integrate together. And this produces an immediate sort of headache of how do I get both of those versions running together and being happy. And at the end of the day, you sort of have to do some mental gymnastics to really figure out a solution to that. I think in the case of Kubernetes infrastructure, the same problem appears in that you may have your service mesh requiring one version of Kubernetes, and internal stakeholders may want to pin to an earlier version of Kubernetes rather than upgrade that quickly. So that's something you need to think about when you're thinking about homogeneous clusters.
So is that a desire for then coordinated version control that you want to be able to drive so you can truly write once and run and deploy anywhere?
Yeah, it helps with that, and that's something that we're going to explore. I think you hit the spokesman message perfectly with that, Jim. Write once, run everywhere. That's something all of us have been hearing since the days of Java, and to some degree, we know that it is something that Java can do, and all of the other solutions like Kubernetes that promise that same thing, they're all capable of it. But we also know there's a lot of gotchas and a lot of caveats that come along with that philosophy, and Kubernetes is similar. So, this helps us get to that philosophy as closely as possible by having homogeneous infrastructure, as you suggested. So that's a great point. And it's worth noting that the outage that we started our conversation with here, the UK bank Monzo, it was caused by very minor version incompatibility between Kubernetes and etcd and Linkerd and Java. The previous version had no problem, but a small upgrade just happened to tweak the API, even though it was a minor version increment, in such a way that the whole cluster sort of came crashing down. So again, this is another reinforcement for the idea that keeping things homogeneous and relatively simple allows you to test a lot further. It allows you to kind of weed out problems like this so you do not run into that same sort of outage. So the other option is to say that sounds like a lot of work, and I know from my personal work that, my company runs a lot of microservices, and we write in Node.js, we write in Ruby, we write in Python, and every team is able to choose the language that they want to run on. We run a polyglot architecture, as it's called. So we should let everyone run everything that they want as maybe one solution, or because the ML AI team has different needs than the e-commerce team on the front end, we should let them run different versions of the software that they need. Well, it's sort of yes and no. And the yes and no of it is just, this is the CNCF landscape. And when you look at the enormity of this landscape, some of these icons are not even visible from this sort of zoomed out view. This is available on CNCF, or I think it's landscape.cncf.io, but it's also linked in the notes at the end of this sort of slide deck. But in any event, there are literally hundreds of projects that we can run on top of our clusters, and while different teams are going to have different needs and we won't ultimately be able to fully be 100% homogeneous, we can still strive for the ideal of homogeneity and cherry pick specific projects for specific teams that do allow us to sort of deviate and resolve their needs in terms of this Kubernetes kind of platform. So what we really want to strive for are clusters that have good defaults, and then we want solutions that are flexible enough to deviate from those defaults or include other services or software when we do finally need that. And this is also why queryability is extra important. Those deviations are going to be the hard things to manage. The homogeneous pieces are hopefully going to be a lot easier to manage, as we all hopefully have experience with. So the queryability and finding those edge cases or those slight differences, that is going to be really key in terms of making that manageable, in terms of looking at the full life cycle of your Kubernetes cluster. You're not just deploying a cluster and forgetting about it. You're deploying a cluster and you're updating it. You're giving it security sort of fixes. You're doing the whole kit and caboodle, and that queryability is going to make that just tons easier. We still need to recognize that data is going to be the hardest part when we're looking at workloads that are running on top of Kubernetes. So we should explore some data-specific tools, some storage-specific tools for Kubernetes itself. I think the classic data issue when we're looking at multi-cluster or multi-workload environment is just how do we do a zero downtime deployment? This is what the dream that everybody wants, and we may have this figured out from VMs. This is a great article from some engineering folks at NC State, sort of detailing how they do a zero downtime deployment for some of their internal services when it comes to moving a database, and that the same exact procedure maps beautifully on top of Kubernetes. We just need to find the right tools to route the traffic in the same way they're talking about routing the traffic or updating, the location of some of their services. So translating some of those little bits turns out to be really important. And if you doubt the importance of this zero downtime mindset, I think this is demonstrated beautifully by my friend Grant Shipley here. He has his kids actually requesting outage windows from him when he reboots the router at home now. So, this is something that everybody cares about. It's not something you get to sweep to the side just because you're serving internal teams. Your customers are sort of your colleagues. They also really want really high uptime, really high availability. And with database workloads, storage, that can be really complicated. That said, we do have procedures for this in sort of the world that we work in and we live in now, and some tools that can help with managing that and doing that on top of Kubernetes in a really simple way are here. So we see all of the basic object storage providers listed here, in addition to two open source tools, Veliro and Minio. Veliro is a really great snapshotting tool for Kubernetes. It'll back up the state of your Kubernetes cluster, can make it really easy to move the manifests and some of the workloads from one cluster to another cluster. You take a snapshot of your data, you snapshot sort of the state of the cluster or the state of the application with Veliro, and you're able to move that relatively easily to another cluster within your whole setup. Minio helps by providing sort of a standard kind of interface across any sort of object storage you might use to either store your snapshots or store some of your backups from Veliro. And I like Minio a lot because it really enables you to think in terms of a multi-cloud mindset. It will provide an object storage if you're managing in your own data center. It'll provide object storage by interfacing with cloud object storage if you then want to consume that in the future. And my developers don't need to update their code to really take advantage of that. Minio is kind of the standard that we can all code against. So that really helps with the homogenization. That said, those tools are relatively simple and they will work for a kind of small Kubernetes setup if you're managing just a handful of clusters. I think for more complex setups, you want to look at solutions like Rook or Portworx or Project Astra, OpenEBS, all of these solutions. These offer things like encryption of data at rest, security profiles, management of your data, automatic snapshotting. They often offer more advanced kind of distributed file systems, things like that. So all of these tools will help connect your storage solutions to your Kubernetes cluster, and they also tend to offer a lot more queryability for you, the storage admin, to manage those different storage workloads from a single sort of interface. So these are the things that they are very complex. There's a big learning curve, but they're very essential when you think about managing tens or hundreds of Kubernetes clusters for your organization.
Well, along the lines of that, Paul, you know, is there a possibility to create an appropriate interface to manage security and at the same time give us enough space to use the clusters? I mean, there's a lot of balance between the customer demand to use the clusters and the security to avoid the conflict. So how would you address that?
Sure. Sorry, could you rephrase that question? I sort of had a blank.
Well, that's fine. I mean, given the need to balance between the customer demand to use the clusters and the security to avoid the conflicts, is there the ability to create an appropriate interface to manage those security problems while we can, you know, give the users the space to still interact and use the clusters?
Yeah, absolutely. And I think all of these tools offer some degree of that. Some are stronger. I would say Portworx and Project Astra, I know, have really strong kind of interfaces for managing those concerns. Rook and OpenEBS may have that. I know they have some solutions, but I'm just not as familiar with them, so they're worth looking into as well. I think in the case of each of these solutions, these are all, I think with the exception of Project Astra, these are all open source. And they all have that capability baked in, but they're all doing it in a slightly different way. So when you adopt Portworx, your implementation for managing security, encrypting your data at rest, doing a lot of other things that may not necessarily work the same way when you transition to OpenEBS. So this is going to be the type of tool that you're really going to want to research and look at and see, does this fit the need of my organization? Can this be sort of the single thing that's consistent across most of my clusters, and bring that homogeneity, that ability to manage this at a large scale to my organization. So yeah, so look at the individual implementations.
So that means it's really important to do your research on what you want to deploy early. It's possible to move between these, but it's very likely that your first choices are going to be the ones that you're going to carry forward in a specific project, right?
Yeah, absolutely. That's a great point. Yeah, thanks. That's a good question. Cool. So we've made it to the end. Congratulations, everyone. We survived the webinar. We've survived the Datapocalypse as presented today. So I want to say thank you for sitting through this. I'll wrap up by, I don't know, being a little philosophic for 10 seconds or so. I think distributed systems are our industry's version of quantum mechanics. Anyone I know who studied quantum mechanics doesn't feel quite right about it. I think the famous quote from Einstein is, God doesn't play dice, was his response to learning that quantum mechanics operate in a random sort of manner. I think distributed systems have a similar effect on us when we think about computing and infrastructure. We all want to believe that we can conquer this thing and we can put it into this old mindset, but the reality is it's wild and weird, and we're all learning together and conquering it together, which is why open source is so great. We're all sharing the strategies that we're using to overcome some of this weirdness within distributed systems. And I think this will apply even if you're not a Kubernetes user yourself. I think other distributed systems like, maybe you're using Amazon's Elastic Container Service, or maybe you're using HashiCorp's Nomad. Those systems will eventually run into similar sorts of problems when you get deep enough with them. So this is something that should translate, I think, across any sort of tool that you wind up using in your work. I think the philosophy, the big thing, is to look for that tool that's going to homogenize and make it scalable and queryable for you. So looking at those solutions that we just looked at are going to be a great thing to start with for you as you look into working with Kubernetes. And I think a great way to start with that is to look at Katacoda. This is a website that offers sandbox environments that they kind of create the environment and then display a shell for you inside of your browser, that, and then have instructions on the side of that shell that will give you a way to play with Portworx or other solutions that are out there. I think they even have the option for you to spin up a Kubernetes cluster knowing nothing about Kubernetes and being able to start using it. So this is a great environment no matter kind of whether you're an expert or a beginner to start with and really look at some of the stuff that's out there. Cool. So that's the bulk of my presentation. I'm going to hand this over to Jim now to wrap up for us.
Thanks, Paul. That was fantastic. I mean, that's a lot of knowledge that's packed in there, and certainly a lot of slide density to be able to communicate it. But that's a very effective way to be able to instruct us to get started on this. Obviously, there's some links here that you can see. This is a continuing presentation in a lot of the work that we've done around Kubernetes in the cloud. And you can see 4 different presentations that we've already done on that. And so you can feel free to look at those links and get more information as we go. Now, we are at the end of the webcast. We do have 5 minutes to the top, or about 4 minutes to the top of the hour, it looks like. Please make sure before you leave to rate this webcast and provide us with feedback. We're very interested in getting better as we go forward, and we'd love to hear what you think of what we're saying and how we move forward. If you have additional questions, you can continue to enter them into the question box, and even if we don't have time to address them today, we will make sure to be able to address those in a follow-up blog at SNIA.org, where we will answer the questions that were asked today, as well as the things moving forward. So a webcast, this webcast and a copy of the slides will be available at the SNIA Educational Library, and you can see the link there. I already talked about the webcast, and then please, if you believe in Twitter, follow us on Twitter at SNIA Cloud. We certainly thank you for attending today, and we look forward to seeing you in a future SNIA Bright Talk podcast or on SNIA.org or at a SNIA conference. We appreciate your time today. Thank you.